Hello students, welcome to the 11th session of physics class. Myself Latha N, Assistant Professor of Physics, Government First Grade College, Sullia. The learning objective of this unit were already discussed in previous sessions. Topics covered in this session are to derive Rutherford scattering formula, to find number of alpha particles which are scattered in between a particular angle. First, we will study about Rutherford scattering formula, or we can derive an expression for Rutherford scattering formula. Consider a thin metal foil on which a parallel beam of alpha particles are incident perpendicularly. In the previous session, we have discussed about how the alpha particle will incident on the metal sheet or metal foil. So here we are considering the same thin metal foil on which the parallel beam of alpha particles are incidenting perpendicularly, and let us assume that any of the alpha particle is scattered by a single nucleus. We are assuming that an alpha particle is scattering by a single nucleus. Then all alpha particles that approaches the nucleus with an impact parameter less than or equal to b is scattered by an angle which is greater than or equal to angle of scattering. So alpha particles which are approaching with the nucleus, it is the perpendicular distance from the nucleus to the direction of alpha particles, that is b. So if an alpha particle approaching the nucleus with a distance which is less than or equal to impact parameter, and it is scattered by an angle which is greater than angle of scattering, then the area around each nucleus with radius equal to impact parameter, that is called as scattering cross section. If we draw a circle taking the impact parameter as the radius, then that circle is called as scattering cross section, that is represented by sigma. So the unit for scattering cross section is barn. 1 barn is 10 power minus 28 meter square. Therefore, scattering cross section is, it is a circle. The area of circle is pi r square. Here the radius is equal to impact parameter b. Therefore, the scattering cross section is sigma is equal to pi b square. Let us consider, let A will be the area of the gold foil and T will be the thickness of the gold. Then volume of the gold foil is area into thickness, that is A into T. Let N be the number of nuclei per unit volume in foil. Then the number of nuclei in the entire volume is nuclei multiplied by the volume, that is AT into N. Therefore, the target area of scattering at an angle which is greater than phi is equal to ATN into sigma. Target area for scattering at an angle greater than the angle of scattering is given by ATN into sigma. Since the total area of the foil is very large compared to scattering cross section, the incident beam cannot aim to strike at any one of the nucleus in the foil. So ಇಲ್ಲಿ ಏನಾಗ್ತಿದೆ, target area of scattering at an angle phi is greater than ATN into sigma ಇರೋದ್ರಿಂದ incident beam cannot aim to strike the any one nucleus. ಯಾವುದೇ ಒಂದು ನ್ಯೂಕ್ಲಿಯಸ್ಗೆ ಸ್ಟ್ರೈಕ್ ಮಾಡ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಆಗಲ್ಲ. Therefore, ಮೂರಲ್ಲಿ ಒಂದು ಎರಡು ಸ್ಟ್ರೈಕ್ ಮಾಡ್ಬೋದು. ಹಾಗಾದ್ರೆ ನಾವೇನ್ ತಗೋಬೇಕು, ಪ್ರಾಬಬಿಲಿಟಿ ತಗೋಬೇಕು. The probability that one incident alpha particle will be scattered at an angle greater than the angle of scattering that is given by F will be the probability of scattering of alpha particle with an angle greater than phi, that is given by F is equal to number of alpha particles scattered at an angle greater than angle phi. ಸ್ಕ್ಯಾಟರಿಂಗ್ ಆಂಗಲ್ಗಿಂತ ಜಾಸ್ತಿ ಇದರಲ್ಲಿ ಎಷ್ಟು ಆಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ ಸ್ಕ್ಯಾಟರ್ ಆಗಿದೆ ಡಿವೈಡೆಡ್ ಬೈ ದ ನಂಬರ್ ಆಫ್ ಆಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ ಇನ್ಸಿಡೆಂಟ್. ಎಷ್ಟರಲ್ಲಿ ಎಷ್ಟು ಗ್ರೇಟರ್ ದ್ಯಾನ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಂಗಲ್ ಸ್ಕ್ಯಾಟರ್ ಆಗಿದೆ ರೇಷಿಯೋ ತಗೊಂಡಾಗ ನಮಗೆ ಪ್ರಾಬಬಿಲಿಟಿ ಸಿಗುತ್ತೆ. Let us assume the number of alpha particles which are scattered at an angle greater than phi is equal to ns, and total number of alpha particle incident will be equal to capital N. Then number of alpha particles scattered at an angle greater than phi is directly proportional to A T N into sigma. Also, total number of alpha particles is directly proportional to area. Then F is equal to ns by n, that is equal to ns ಅಂದ್ರೆ ATN into sigma, and A is proportional, n is proportional to A ಆಗಿರೋದ್ರಿಂದ ಈ ಅಷ್ಟೇ ತಗೊಂತೀವಿ. A will get cancelled, then we get F is equal to sigma n into T. So we know that sigma is equal to scattering cross section, that is pi b square. Therefore F is equal to pi b square n into T. So we know the expression for impact parameter, that is d by 2 part phi by 2. Therefore F becomes pi nt into d by 2 part phi by 2 whole square. D is called distance of closest approach. We know that distance of closest approach ಗೆ ನಮಗೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಗೊತ್ತಿದೆ, d is equal to 1 by 4 pi epsilon naught 2 z e square by k ಅಂತ. ಅದನ್ನ ಇದಕ್ಕೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ F is equal to pi nt by 4, d ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಇದೀವಿ 1 by 4 pi epsilon naught 2 z e square by k whole square into ಸ್ಕ್ವೇರ್ ಇರೋದ್ರಿಂದ ಕಾಟ್ ಸ್ಕ್ವೇರ್ 5 by 2 ಆಯ್ತು. 2 ಸ್ಕ್ವೇರ್ಗೆ ಮತ್ತೆ ಇಲ್ಲಿ 4ಗೆ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. z e square divided by 4 pi epsilon naught k whole square cos square 5 by 2. Call this as equation number 3. But in actual experiments, the detector measures alpha particles scattered between phi and phi plus d phi. ಜನರಲ್ ಆಗಿ ಅಷ್ಟು ಸ್ಕ್ಯಾಟರ್ಡ್ ಆಗಿರುವಂತ ಪಾರ್ಟಿಕಲ್ಸ್ ನ ಮೆಜರ್ ಮಾಡೋದಿಲ್ಲ ಪ್ರಾಕ್ಟಿಕಲ್ ಆಗಿ ಡಿಟೆಕ್ಟರ್. ಸರ್ಟನ್ ಆಂಗಲ್ ಅಲ್ಲಿ ಎಷ್ಟು ಸ್ಕ್ಯಾಟರ್ ಆಗ್ತಿದೆ ಅನ್ನೋದು ಮಾತ್ರ ಡಿಟೆಕ್ಟ್ ಮಾಡ್ತಿದೆ. ಹಾಗಾದ್ರೆ how many fractions of alpha particles scattered in between a particular angle, that is obtained by differentiating equation 3. Then differentiating this equation 3 we will get df is equal to pi nt z e square divided by 4 pi epsilon naught k whole square part. ಇದನ್ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಡಿಫ್ರೆನ್ಶಿಯೇಷನ್ ಆಫ್ ಕಾಟ್ ಸ್ಕ್ವೇರ್ಗೆ 2 ಇಂಟು ಪಾರ್ಟ್ 5 by 2, ಪಾರ್ಟ್ಗೆ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದಾಗ ಮೈನಸ್ ಕೊಸಿಕೆಂಡ್ ಸ್ಕ್ವೇರ್ 5 by 2 ಇಂಟು 5 by 2 ಇಂಟು ಡಿ 5. ಫರ್ದರ್ ಮೈನಸ್ ನ ಹೊರಗಡೆ ತಕೊಂಡು ಪೈ ಎನ್ ಟಿ ಝಡ್ ಇ ಸ್ಕ್ವೇರ್ divided by 4 pi epsilon naught k whole square part by 2. This 2 and this 2 will get cancelled. Here cosecant square 5 by 2 into d5. Call this as equation number 4. Here the negative sign indicates that the probability of F decreases as phi increases. Angle ಜಾಸ್ತಿ ಆದಂಗೆಲ್ಲ probability ಏನಾಗುತ್ತೆ ಕಡಿಮೆ ಆಗ್ತಾ ಇರುತ್ತೆ. If the total number of alpha particles incident on the foil is equal to n, then total number of alpha particles scattered between the angle phi and phi plus d phi is equal to n into modulus of df. Call that as equation number 5. Next, we have to find the number of alpha particles which are scattered in between phi and phi plus d phi. Consider this diagram. Here, the number of incident alpha particles which are being scattered through an angle phi and phi plus d phi. ಇದು phi, this is d phi ಅಂತ ಅನ್ಕೊಂಡ್ರೆ ಇಷ್ಟ್ರ ಮಧ್ಯೆ ಎಷ್ಟು ಆಂಗಲ್ ಸ್ಕ್ಯಾಟರ್ ಆಗ್ತಾ ಇದೆ ಅದನ್ನ ಏನ್ರಲ್ಲಿ ತೋರಿಸ್ತಾ ಇದೀವಿ, ಈ ಶೇಡೆಡ್ ರೀಜನ್, ಇದು ಮತ್ತೆ ಈ ರೀಜನ್ ಅಲ್ಲಿ, ಈ ಶೇಡೆಡ್ ರೀಜನ್ ಅಲ್ಲಿ ಏನಾಗಿದೆ, ನಂಬರ್ ಆಫ್ ಇನ್ಸಿಡೆಂಟ್ ಆಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ಸ್ ವಿಚ್ ಆರ್ ಬೀಯಿಂಗ್ ಸ್ಕ್ಯಾಟರ್ಡ್, ಎಷ್ಟು ಸ್ಕ್ಯಾಟರ್ ಆಗ್ತಿದೆ ಈ ಆಂಗಲ್ ಅಲ್ಲಿ ಅಂತ ಸಿಗ್ತಾ ಇದೆ. ದಿಸ್ ಈಸ್ ದ ಆನ್ಯುಲರ್ ರೀಜನ್. ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ಹಿಯರ್, ಇದು ಒಂಥರ ರಿಂಗ್ ಶೇಪ್ ಅಲ್ಲಿ ಕಾಣ್ತಾ ಇದೆ. ಆಫ್ ರೇಡಿಯಸ್ ಎಷ್ಟಿದೆ, ಇಂದ ಇಲ್ಲಿ ರೇಡಿಯಸ್ ಆರ್ ಸೈನ್ ಫೈ. ಬಿಕಾಸ್ ಇಲ್ಲಿ ಸೈನ್ ಥೀಟಾ ತಗೊಳ್ಳೋದಾದ್ರೆ ಫೈ, ರೇಡಿಯಸ್ hypotenuse is r, sin theta is equal to opposite by hypotenuse. Sin theta is equal to opposite divided by hypotenuse is r. Therefore opposite is equal to r sin theta. ಇಲ್ಲಿ ಬರ್ಕೊಂಡಿದ್ದೀವಿ. So the annular ring radius ಎಷ್ಟಾಗಿರುತ್ತೆ ಹಾಗಾದ್ರೆ r sin phi and its thickness is r into d phi. ಇಲ್ಲಿ d phi angle ಇತ್ತಂದ್ರೆ arc length ಏನಾಗುತ್ತೆ, radius multiplied by angle, that is r into d phi. So where r being the distance of gold foil from the screen. ಈ ಗೋಲ್ಡ್ ಫಾಯಿಲ್ ಇಂದ ಸ್ಕ್ರೀನ್ ಇರುವಂತ ಡಿಸ್ಟೆನ್ಸ್ ನ r ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ವಿ. The area of the shaded region is given by ds is equal to, shaded region is the circle. Area of circle is 2 pi r. Here 2 pi r ಅಂದ್ರೆ r sin phi. ಇಲ್ಲಿ ಏರಿಯಾ ಬೇಕಾಗಿರೋದ್ರಿಂದ multiplied by its thickness, that is r into d phi. So therefore area of the shaded region is ds is equal to 2 pi r sin phi into r into d phi. So n phi is the number of alpha particles scattered per unit area of the screen between the angle phi and phi plus d phi. Let us assume number of alpha particles which are scattered per unit area of the screen will be equal to n phi. Then total number of alpha particles scattered in between phi and phi plus d phi is n phi into ds. Let us call this as equation number 6. So this 6 will be equal to 5 irutte. Therefore n phi ds is equal to fraction of alpha particles which are scattered in between phi and phi plus d phi. So will be same. Therefore substituting for df and ds will get n into df is pi nt z e square divided by 4 pi epsilon naught k whole square, whole divided by the value of ds is 2 pi r square sin phi d phi into part 5 by 2 cosecant square 5 by 2 into d phi. So ಇದರಲ್ಲಿ n pi will get cancelled, z square e power 4 after squaring, here 4 pi epsilon naught k whole square ನ ಒಳಗಡೆ ತಕೊಂಡಿದೀವಿ. Then part theta ನ cos 5 by 2 divided by sin 5 by 2 ಅಂತ ಬರ್ಕೊಬಹುದು. cosecant square 5 by 2 ನ 1 divided by sin square 5 by 2, 2 ಇದೆ, r square ಇಲ್ಲಿ ಬರ್ಕೊಂಡಿದೀವಿ, d phi divided by ಈ sin phi ನ sin 2 theta ನ 2 sin theta cos theta. The same way sin phi will be equal to 2 sin pi by 2 into cos phi by 2. ಅದನ್ನ ಇಲ್ಲಿ ಬರ್ಕೊಂಡಿದೀವಿ. ಅದ್ರಲ್ಲಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ n n t z square e power 4. So here 2 into 2 2 square 4 into 2 whole square ಆಗುತ್ತೆ 8 pi epsilon naught whole square k square ಈ ಕಡೆ ಬರ್ಕೊಂಡಿದೀವಿ r square here cos pi by 2 cos pi by 2 will cancel and the remaining is sin pi by 2 into sin square pi by 2 sin cube pi by 2 into sin pi by 2 will be sin power 4 pi by 2. Call this as equation 7. So in 1930, Giger and Marston verified this equation experimentally by changing one factor at a time and keeping others constant. Thus, the equation shows that n phi is inversely proportional to sin power 4 phi by 2 if k, r, t and z are constants, and n phi is inversely proportional to square of the distance between the screen and gold file if k, r, z and phi are constant, and n phi is inversely proportional to square of the kinetic energy if t, z, phi and r are constants, and n phi is directly proportional to t, z, phi, r and k are constant, and n phi is directly proportional to square of the atomic number if phi, r, k and t are constant. This equation 7 is Rutherford scattering formula. The references for this session are listed. Thank you.